and welcome to this Express webinar. Thanks for joining. Today's topic will be the knowledge discovery process and how we can extract vocabulary and relationships from legacy textual documentation. So before we start, let me guide you through some housekeeping rules. You will be muted all along the webinar. If you have any questions or comments, you can send them through the chat box, and please address them to the Reuse Company host. And if you have any technical issue, please let me know through the chat box or contact support@reusecompany.com. And please note that this webinar is being recorded and that the recording will be available within a few days. So let's get into the topic. As you can see from the title that is displayed, this is a short webinar. So the idea is not to detail all the process, but more to give you introductory content to have you get you aware of this this process that we are presenting.
And I can.
So just a few words about myself. I'm Ilyas Yousfi. I'm part of the sales and consulting team at the Reuse Company. And as a consultant, I've been facing many challenges regarding the topic of today, which is that customers are often asking themselves how they can extract knowledge and reuse this knowledge for other projects, for other systems. And this is something that we faced a lot of times in the last couple of years. And so that's why we came up with this process to help ensure that we use knowledge consistently and that we can repeat this process a high number of times. So if you have any questions, as I told you, this is a short webinar. So if you have questions, of course, you can address an email to this email address here, and we can keep discussing this further in another meeting. So just to introduce you to the content, first we will be asking ourselves why capturing knowledge in legacy documentation. So I'll be focusing on textual documentation. There's a webinar coming up in 2 weeks, which is focusing on models. But here I'm going to talk about textual documentation. So which is the main one of the main sources of knowledge in a system development project. Then we will be defining what is an ontology and how the ontologies support the knowledge extraction. And then I'm going to present you the process based on NLP, natural language processing, and semantic analysis. And then a short demo to show you how this is processed. So first of all, why are we capturing knowledge from documents? So the first aspect is saving time, which is the main aspect of a project. As you know from some guidelines like INCOSE Guide for Writing Requirements, some rules that are applied in the guide will depend on the context. So you have to define the context, define the concepts you're using in your project to make sure that you will be assessing the quality properly. So you need to extract this information from somewhere, and you need a process to do it seamlessly and efficiently. Second aspect is the rising complexity. So you have to repeat this process lots of times because there's a rising number of documents to define the system functionality and the system in general. And the documents are of many different kinds. So you need a process that is neutral in terms of documentation. So for example, a human can read an Excel sheet differently from a Word document and differently from a DOORS module. Here, the idea is that we can read all these documents the same way and using the same process. And thirdly, and most importantly here, the reasons of reasons, knowledge is invaluable. For example, knowledge management is a key project enabling process in systems engineering. And you have to imagine that this process is fueling all the other ones with information, with input. So knowledge management is key in defining the system. So just a quick recap here of what is the manual inspection of requirements and work products in general versus automated assessment. Basically, the rules defined on paper will be converted into computed metrics the requirement types will be covered by different patterns that will sketch, let's say, shape the way the requirement should be written, and vocabulary will be organized into what we call an ontology. I will get to it a bit later. And this is what helps saving time and also depending less on the subject matter experts that work on the project. And here a quick overview of the project enabling processes here from the INCOSE Systems Engineering Handbook. And you see that the purpose, as defined by this handbook, is to exploit opportunities to reapply existing knowledge. So you have here the what I said in the beginning, that everyone wants to reuse the knowledge, and we have to guarantee that this can be done easily. So going back to this image, you have the ontology here that we should define, and that is what I'm going to talk about next. So ontologies to support knowledge extraction. The first question, what is an ontology? At the beginning, this was a philosophical concept, and what is more interesting today is the technological concept it has produced, which is basically how we represent the knowledge, how we structure the knowledge in our project. And the common ground of both definitions is asking ourselves, what do we have and what do we need to understand our world, our system, our environment, and what we need is knowledge. So in our case, the ontology will be defined as a conjunction of different concepts here. I'm not going to go too much into detail here, but basically what you have to keep in mind is that this is the way we represent knowledge, and these elements will help the ontology to self-feed detecting new information, and then this information will be itself organized in this way. So this bubble here will be growing, and the more information you have, the more efficient will be your requirements assessment will be. So now that I introduced the key element, the cornerstone of the process, I'm going to talk to you about this knowledge discovery process that I was mentioning at the beginning that helps people using and reusing knowledge. So this is a 5-step process, and you see on the bottom part, knowledge mining is iterative. So the key aspect here is that this process should be repeated and will be repeated a certain number of times. So the first step is to define the problem, what kind of elements you would like to detect in documents. So would you like to detect actions, systems, system modes, any kind of information that you can find in your document. And this will be related to the second step, which is understand the sources you will be looking into. So what kind of documents you are looking into, and who wrote these documents, and so on. After that, you process the knowledge, so you get the ontology on board to start analyzing the documents, and you keep developing the model, which I mentioned earlier with this ontology representation. And after that, you select the knowledge you would like to get into the system, so get into the ontology, and the way you would like to import it. Because one thing is in detecting the knowledge, the other thing is how will it be represented. And so the user has the say in the way it is going to be represented. And last step here will be to rate the results that you have. And if you're not satisfied, then you can go back to the step number 1 or number 2, depending on the information that needs to be completed. So the first step, define the problems. So for those who are familiar with our tools, this is RQA, the quality assessment tool. And here, this is a list of metrics. This time, not a list of metrics to check the quality of the requirements, but this will be a list of metrics to define what will be detected in the document. System names, states, transitions, standards, actors, can be anything you have in a document. And then you will see later, the result is the list of elements that should be detected. Second step is the list of documents, the documents you will be analyzing. So these documents can be Excel sheets, Word documents, and Doors modules. So as I said, a human will read these documents differently. So in Excel, I will look into the columns, I will look the worksheets and organize my review following these aspects. In Word, I will look into the styles of the document. So do I have headings? Do I have different chapters? And so on. And indoors, I will use the attributes, like so very similar to Word here, to Excel, sorry. It's very similar to Excel with the columns, but this time the attributes, some of them are generated automatically, like the ID, for example, and you can generate attributes and views using doors. So the object is different, but in all of the cases, you have to think of the purpose of the document. So what is the document written for? What is the level of system abstraction? And what are the authors of the document? After that, you have the knowledge processing. So using the ontology, this is KM, Knowledge Manager, for those who are familiar with the tool. This is the list of vocabulary that you have here. So this is not the only thing you have in an ontology. As I said, you have also clusters, so some sort of containers of similar meaning terms, like components here, for example. And you can have relationships here, for example, a property with a measurement unit. And after that, the step number 4 is knowledge deduction. So you run the process on RQA using the metrics, and you get informations you would like to import with the numbers, the frequency of appearance in the document. So this helps knowing that your document is mainly talking about this or that system. And then you use this information, you put it in an Excel sheet to make it ready for importing in the ontology using the KM, using this importation wizard. I will get to it during the demo. And last step is rating the results. So you look at the quality results, you look at the metrics involved. If you have any metric that is pointing to an unknown term, an unknown acronym, this means that you have to repeat the process. And I will show you an example during the demo. So that's it for the theoretical part, let's say. So I'm going to get into the demo right now, and I'm going to start here being inside RQA. So RQA here is presenting so the different requirements in a tabular view with the different results. So I'm running an assessment with the second baseline of our knowledge library for the INCOSE guide for writing requirements rules, which is including the main specific metrics. And as you can see, this is to show you how it is when you don't have vocabulary in the document. So if you don't have vocabulary in the document, the result will be very low because most of the metrics will be related to the fact that we don't have vocabulary related to the system in the ontology. So knowing that, being aware of that, the next thing we're going to do is to apply our set of metrics to detect vocabulary. So this is the first step that I show you in the presentation. So you have a list of metrics, some to detect standards, to detect system names, actions, and this way you are defining the problem, what kind of information you're going to detect. So you will see that the results we're going to have here are not very important, the stars here. More important are the information that the metric is gathering. So this will be the list of terms that we're going to use. So looking into the metrics, you can see here that we have different issues, but these are not considered as issues of syntax. These are list of terms that we don't have in the ontology. So you can have states names here, or just before we had some terms, and you can copy this information into an Excel sheet, and this Excel sheet will be used to get the information inside the ontology. So you can copy here inside a metric the information and put it in an Excel sheet. Here I'm using a template. You'll see to extract the word from the result of the metric. So you see that now I having the words, and I can repeat the process until the end, and then I have a list of information. I can remove the duplicates detected by the metrics and start ranking the elements to put them in the ontology. So you can see here that, for example, activity and activity of the temperature warrior are kind of related, but here you have to decide which term will be the one that you will be classifying into the ontology. So the ontology is not just a list of simple terms. You have also compound terms, and you can decide that, for example, authentication is not a valid term, but authentication mode is. So you have this level of definition in the vocabulary. This is not just a glossary of single terms. So you do this with all the terms, terms that are nouns, adjectives, and if you have a state, for example, authentication mode is a state, then you can filter, look for the modes, and put that the mode is a state for all the modes detected in the vocabulary. So this is your process of selecting the knowledge. This is what you're doing. I'm going to speed up a little bit because you do this for all the terms. And then once you finish, you can remove the lines that you didn't classify. These will not be imported into the ontology. And then you have your final list of elements that you will be importing. So once you have this defined, you can save your worksheet and go to your knowledge manager and start importing. So you select the worksheet, which column will be the term tag, which is the language category, the part of speech used. Is it a noun? Is it a verb? And then the cluster, which is, as I said, a category with words of similar meaning. And once you do this, you see that 52 terms are being created. You can save this, and if you rank by identifier, you'll see that the terms we created are inside the database. So for example, web interface, that was the last term in the worksheet. You see that it's right here. You have the modes, temperature warrior. We saw that it is the main term appearing in the document because this is our system, and so on. So next step is going back to RQA and applying this INCOSE baseline that includes domain-dependent vocabulary, and see if we improved the quality just by importing vocabulary. I didn't do anything with the document. I didn't change the content of the requirements. What I just did is feed the ontology with new vocabulary, and you will see that the difference is quite significant. You see that now we're reaching a result of above 50%, so 67 in this case. And here we're rating the results. So for example, we see that some terms are considered unclassified. So we can repeat the process, copy these terms that I have here, and go to the worksheet and bring this information into the knowledge base. So basically, I can use exactly the same worksheet because the tool will be reminding that these words were already imported into ontology. So I can use the import wizard without saying that, so without deleting the rest of the lines. So if I do this and classify the information, then I can go to the import wizard again, and you see that I have only 4 created terms because the process was already done for the rest of the terms. And you see the terms are created, you can save, and then go back to RQA, and you can see that after running another assessment, it will be increasing a little bit the quality assessment. So you will see that here it's slightly increasing. We have now not 67, but 70%. And the last step here would be, what about adding a new component to the knowledge base? Something that we didn't here. By the way, you see the unclassified terms, 0. So now we are okay with the metrics we used so far to detect knowledge. And what I was saying is, what about adding a new component? And this time I'm not going to add vocabulary, I'm going to add relationships. So I will be detecting relationships in a document. So let's go back to the metrics that are used to extract vocabulary. So we go back to problem definition, and since we already used this here, we can add a new metric to detect relationship. So here in this case, I'm going to extract system structure relationships. So what we call PBS, for product breakdown structure. And we are going to add this into the PBS relationship and select the pattern that will be used for the detection of the relationships. So when I said that the ontology is self-feeding, of course, to be able to detect relationship between system names, you have to first detect the system names. So that's why here it reinforces the idea that it is an iterative process and you need the information about the system names to be able to detect relationships. And here we are adding another feature, which is the filtering. I want to look into the requirements of type architectural, so defining the architecture of the system. And here I can do something else in the configuration, which is filtering the result to be looked only with this metrics, which speeds up the process because I only calculate with one metric, not with all the bunch of metrics we have. And you see the result, just one metric, because we already had the other ones, and we detect some relationships. So same process as before, we can take these relationships, select it, and go to the Excel sheet, the same we used so far, and use our here worksheet to extract information. So using this information here, I'm here detecting information that I will be importing in KM. So I have an importation wizard in KM, which enables me to define the two terms involved in the relationship. And this way I can create my system structure. So going back to the KM here, now we are in the second layer of the ontology. Remember, the ontology has 5 layers. Here we are in the conceptual model. And I'm going to import relationships from the Excel sheet. So here I have an importation wizard. I'm selecting the worksheet that I just copied the information into, the relationship I want to import into. And here I'm detecting the columns of the relationships of this worksheet. And I'm going to select that the first term of the relationship will be the term 1 column, and the second term, the term 2. And here I'm going to include as well that both terms should be imported in component. And then once we do this, you see that we generate a relationship tree of the system structure. So we're detecting information from the text and we're getting this information inside an ontology that will be reused as much as possible for further projects. So now, if you have any questions, any comments on this approach, any suggestion, please let me know through the chat box. I'm going to give you some time to ask your questions or give any of your comments. And in the meantime, I'm going to talk to you about the next webinar that is to be held in 2 weeks now, on December 14th and 16th. And the webinar will be kind of the next episode of this series about knowledge extraction, this time considering the models as a source of information to enhance the domain-specific assessment of requirements quality. So any questions, any comments? You have maybe time for 1 or 2 questions. So in any case, if you have any question, any suggestion, any comment, please let me know sending me an email or contacting us through the Reuse Company website. Then I have now to say you thanks for your attention and looking forward to meet you for another meeting, another webinar of the Reuse Company. Thank you. Have a nice day. Bye.